What's up? What's up? Today we're talking about the introduction of rational expressions. So we're going to hit three things here today. We're going to talk about one, we're going to talk about when a rational expression is undefined. Two, we're going to talk about how to simplify rational expressions. And three, we're going to talk about multiplying rational expressions. Okay, so those are going to be the three things that we're going to talk about today. Actually, I don't like this because I wrote everything in caps. There we go. All right, so those are three things we're going to talk about. So the first thing we're going to talk about is about well, first of all, let's talk about this. The word rational is just a fancy word for fractions. Okay? Fractions like A over B. Okay? So it's just talking about fractions. All right? So if I'm saying when a rational expression is undefined, that means when is a fraction undefined. So a fraction is undefined when the bottom or the denominator is equal to 0. Okay? When it's equal to 0. So, actually I probably shouldn't do this because there is another meaning in math with that. So 0, there we go. So, in other words, if I have 5 divided by 0, 5 over 0, if you put this in your calculator, you will get error. Okay? Or you'll see like a symbol of E somewhere on your calculator that tells you is an error because that's when it's undefined. Now, where 0 over 5, that's equal to 0. Okay? So, understand that the one on the left means undefined, and the one on the right actually has an answer. This is 0. Okay? So the numerator doesn't really matter if it's a 0 or not. That's okay. It's when the denominator is a 0 that we have issues. Okay? So we're only focused on the denominator. So when the homework asks you, when is this rational expression undefined? That's when you go, okay, so basically they're asking when is the denominator 0? So for example, if it was 8x cubed plus 7x squared plus 2 all over, let's say 3, okay? Well, again, our focus is on just the denominator. So when we're looking at this, we're saying when will 3 become 0? And the answer is never. 3 is 3. Okay? So this will never equal to 0, right? So therefore, there is, this rational expression is never undefined. Okay? The domain the word domain means what possible x values can I use? So I don't know if they're going to ask you about domain, but we're going to talk about it. So this is asking what numbers can we put in this case x, because the variable in here is x's. What numbers can we put in for that? Well, because there's nothing that's undefined, then the domain is all reals. Let me draw that prettier. X such that x is all reals. Okay? So, I know that doesn't really clear things up, but that is the simplest example I can give at this time. Okay? So, domain is what values can I give these variables that will still give me a fraction. And since 3 would never become 0, this rational expression is never undefined. That's why when it says all reals, it means I can use any values for x. Okay, let me give you another example. Let's say I got 5x squared minus 3 over, let's undo that. Let's actually do a line here so it looks better, over x minus 1. So again, it's going to ask you, when is this fraction or rational expression undefined? So when it asks you anything, we always look at the denominator and say, okay, so what would make x minus 1 undefined? So what you would do is literally take the denominator, x minus 1, and set it equal to 0. Let's see what would make it 0. So we go, okay, so we add 1 to both sides. And we have x is equal to 1. So when x is equal to 1, which makes sense, right? If I plug x back in here of 1, 1 minus 1 would make it 0. Okay? So the rational expression is undefined at x equals 1. Okay? So if it was to ask for domain, you know what I should do? I should just make this a totally separate thing here and make that blue. Okay, so over here, if we were to find a domain for this one, we'll say that x such that x is all reals and x cannot equal to 1. Okay, so that's just all the domain is saying, okay, I can use any other x values except I can't use 1, because if I put 1 in for x, then I'll have 1 minus 1, which is equal to 0. So then I'll have a fraction that's over 0, which makes the fraction undefined. Okay? So that's all that's saying. Okay? Another example. So 7x minus 2 over x squared minus 2x minus 15. Uh-oh, I've seen this before. So again, I'm still looking at just the denominator if it's asking when is the rational expression undefined. So if you notice so far, I've only focused on just the denominator. Anytime I ask if the when is the rational exponent undefined, I focus on just the bottom. Okay? That's all that matters. The numerator doesn't matter. The numerator can be 0, right? And when the numerator is 0, it just is 0. That rational expression is 0. That fraction is 0. So in this case, I focus on just the denominator. So I gotta say, okay, I got x squared minus 2x minus 15 is equal to 0. All right, well, how do I do this? Well, we just did this. right? We just did these problems. These are called quadratic equations, where I had to factor the non-zero side. Okay, you can go AC method if you want to. So you can use the AC method or trial and error. And with AC method, this is going to come out as x minus 5, x plus 3. And then what we will have to do is set each factor equal to 0. So x equals 5, x equals negative 3, okay? So yes, the factoring continues on. So you didn't get enough practice in factoring, you better practice more, all right? And this is gonna go into the next course as well. This is gonna extend to the next course. Factoring is gonna come back to haunt you over and over and over. This is probably the second most hated concept in math. First is fractions, and then the second would be factors, okay? So, this rational expression is undefined at x equals 5 and x equals negative 3. Okay, so again, the domain becomes really easy because the domain would be domain, meaning what x values can I use? X such that x is all reals, and x cannot be negative 3, and x cannot be 5. So that's all it is. So notice how the domain really isn't too bad, meaning I can use all the x values, but whatever I find to make that fraction undefined is what I would throw over here, okay? Same thing here, look, 5 and negative 3 doesn't make it, will make the fraction undefined, so therefore I say x cannot equal to that, nor equal to the 5, okay? So again, if it asks when is the rational expression undefined, take the denominator, set it equal to 0, solve, okay? And then that's all you got. So yes, factoring does come back to play. So let's talk about factoring really quick, okay? So with factoring, come on. Right? With factoring, the first step is what? GCF, okay? So after GCF, what do we want to do? We want to see how many terms there are, right? There can be possibly 2 terms, right? With 2 terms, what do? We ask ourselves the question, is it the difference of 2 perfect squares? It could be 3 terms. If it's 3 terms, what do? We do the AC method, right? And it could also be 4 terms. What do we do with 4 terms? Factor by grouping, okay? So all of these things could happen. So let's do this. So all of those things can happen. But again, factoring we've got to first do the GCF, then 2 terms, 3 terms, or 4 terms, okay? So that's just a reminder. So you may have to go back to the notes on factoring to kind of review this. And most likely you're going to have to end up saying things equal to 0. So that would be the quadratic equations, which you had the standard form, right? So quadratic equations, right? We had the standard form, which is ax squared plus bx plus c equal to 0. Okay, so we did have that as well, right? So that is called the standard form, all right? Okay, so that is how you would find if a rational expression is undefined. Okay, so what's 2? 2 is simplifying. So let's talk about 2. So 2 is simplifying rational expressions. Okay, so again, we're simplifying fractions essentially. Okay, however, it's not going to be as easy as you might think it's going to be because we're bringing back factoring. So let's do an example here. So we might have something like this: x squared plus 3x plus 4 over x squared minus x minus 20. Okay. So I have steps on this as well. So let's talk about these steps. So these steps, step 1, I'll start up here, is to factor top and bottom. Okay. So we're going to take, let's do this here. Let's make this one blue. And let's make this bottom one orange. Okay. So let's go into the blue one really quick. So we have x squared plus 3x plus 4. Okay. So we'll review the AC method here. So we got a times c is equal to 4, b is equal to 3. So the two numbers I need is I copied this wrong. I was getting confused myself, but wait a minute, this is not going to work. So this is minus 4, minus 4. So negative 4 here. So the two numbers I need is 4 and negative 1. Okay, so 4 times negative 1 gives me negative 4. 4 plus a negative 1 will give me a positive 3. So let me change these colors as well. Let's change it to orange. All right, so that means I have to go x squared. I'm going to use negative first. Minus 1x plus 4x minus 4. And then I have to factor by grouping. So I want to cut down the center here. Saying, okay, what's the GCF in my first group? And you're going to say an x, leaving me with a x minus 1. My GCF in the second group is 4, and that would leave me with also an x minus 1. So therefore, what's in common as a whole, x minus 1, and leave me with a x plus 4. So there's my factoring on the top side. So let me do this really quick. Draw this line. So my top side is going to be x minus 1, x plus 4. Okay? So now I got to factor the bottom, and the bottom is in orange. So I have an x squared minus x minus 20. My a times c is equal to negative 20, while my b is equal to negative 1. So I need to find those two numbers, and those two numbers are going to be -5 and 4. Because if I multiply those two, -5 times 4 is giving me -20. -5 plus 4 gives me -1. So okay, so now I have x squared minus 5x plus 4x minus 20. I'm going to split this down the middle. GCF of the first group is x. Leave me with a x minus 5. GCF of the second group is 4. Leave me with a x minus 5. So it's going to be x minus 5 and an x plus 4. So I come back up here. This is done. So this is going to be a x minus 5 and a x plus 4. Okay? So from there, what I can do is reduce. Okay? So if you notice that, let me use a different color here. Notice that x plus 4 and x plus 4 is in common. And x plus 4 divided by x plus 4 is going to equal to a 1. Okay? So if that's going to equal 1, I can basically cancel those out. So I'm left with x minus 1 over x plus 5. X minus 5. And that would be my answer. Okay? So step 2 was to simplify. So maybe you got to cancel. Okay? So again, I factor top and bottom. I got that. See if there's anything in common with top and bottom so that I can cancel them out. The x plus 4 is in common, so I can cancel those out. So I'm left with the x minus 1 and the x minus 5, and then that would be my answer. And that's it. Okay? So that's how you simplify. Now, with that being said, you also need to remember this example, because this example will come handy dandy. 7 minus y over y minus 7. Okay? So if you notice that this right here, that on top the 7 is positive, the y is negative. Okay? While the bottom, the y is positive and the 7 is negative. Okay? So in other words, comparing the top with the bottom, basically the signs got switched. Okay? So let me write that down. So on the top, the 7 is a positive and the y is a negative, while on the bottom, the 7 is a negative and the y is a positive. So if you notice, the signs basically flip from the top to the bottom. So, with that being said, what if I just do a GCF of a -1 from the top? So if I do a GCF of -1 from the top, so if I pull a -1, what would I have? Then I'll have a -7 plus y. So if you don't believe me, okay, this is again just the top, okay? And if you don't believe me, distribute this back in and see if I get the top back again. And the answer is going to be yes, you will, okay? So, and then the bottom, I'm going to just leave alone. Okay, so if you look at this, I got a -1 here. The top I can rearrange, okay? Because 2 plus 3 and 3 plus 2 means the same thing. That's called the commutative property. So I can rewrite this as y minus 7 because the y is positive, the 7 is negative, over y minus 7. And since these two are in common, all I have left is a -1. Okay? So again, notice how the terms are exactly the same, except the signs are opposite comparing top to bottom. If that is the case, I can actually cancel those out and get -1. However, that does not work if I had 7 plus y over y plus 7, that's just going to equal to a 1. Okay? So remember the difference. This is subtraction. This is addition. Okay? The top 7 is positive, so is the bottom 7. The top y is positive, so is the bottom y. Okay? So these two really mean the same thing, because I really could just rewrite this top as a y plus 7, which is the same as the bottom. Okay? All right. So enough of that. Let's talk about the third part. Part 3. Part 3 says that I'm talking about multiplying rational expression. Okay? Whew. Welcome. Here we go. Same rules as simplifying, as multiplying, because multiplying rationals, so when we multiply rationals, so if I have two fractions, a times b times c over d, that's going to equal a times c, top times top, over bottom times bottom. Okay? Now, even with that being said, let's use numbers, right? So I could do 1/2 times 2/3. Well, when I do that, I do top times top, bottom times bottom. But what we notice is that the 2 and the 2 are the same, so they will cancel out, and I'm left with 1/3. Okay? All right, so let's take another example. Let's say it was 1/4 times 2/3. Okay? So same thing. 1 times 2 on top, bottom is 4 times 3. So here's the other way of canceling this, because instead of going 2 over 12 and then trying to reduce that because the numbers get kind of big as we go along, what I can do is break these down. So I can break down the 1, well, the 1 is just a 1, the 2 is just a 2, because I can't break down 2 anymore because that's already a prime. But I can break down the 4 as a 2 times 2, and then the 3. Okay, so now I can say, look, the 2 and the 2 isn't common. So what I have left is 1 over 2 times 3, which is 6. So then that would be my answer. Okay, so same idea, all right? But essentially, I'm starting with multiplication, but what ends up happening is that it becomes the top is all together and the bottom's all together anyways. So let's take a look at an example that would be what you would see in this particular section. So let's do something simple like 10x plus 10 over 3x plus 9 times x plus 3 over 5x squared minus 5. Okay? So, step 1 is the same as above, which is factor top and bottom. Okay? All right, so now I got to factor. I got to factor each one. So now I got to factor 4 times. Yikes. So let's change all these to different colors. That one right there, let's call it red. This one over here, let's call it blue. This one over here, let's call orange. And then this one down here, we'll call purple. Apparently, I didn't cover all of that, so that was orange. All right, there we go. All right, so let's factor the first part. The 10x plus 10 GCF is all we need, because then they'll be left with x plus 1. Okay? Now, we have this line. Now we need to factor the bottom. The bottom, same thing, GCF, 3, leaving me with x plus 3. Okay? I'm going to try to draw my line right here. Now, x plus 3 is already done, no GCF. The 5x squared minus 5 has a GCF. That's supposed to be purple, not blue. So I got 5, leave me an x squared minus 1. Then I'm like, okay, so what else do I gotta do? But wait, am I done factoring? No, I'm not. Why is that? Because x squared minus 1, actually, you know what? Let's do this. Because x squared minus 1, because there is a purple here, this x squared minus 1 is actually the difference of two squares. So that actually factors further to x minus 1, x plus 1, because that's the difference of two squares. So now I got to rewrite the whole thing. So I got here 10 times x plus 1. I have 3 times x plus 3. I got the x plus 3, and I have the 5 times x minus 1 times x plus 1. Okay? Wow, that's really big. Okay. Now I'll go back to this and put my lines in. There we go. Okay? So since I'm multiplying, it's top times top, bottom times bottom. So I have 10 x plus 1 times x plus 3 all over, whoa, that does not look that way. There we go. Is that better? And then the bottom, I have 3 times 5 times x plus 3 times the x minus 1 times the x plus 1. And notice how I put all the numbers in front. And while I'm at it, what I should do with the 10 is actually break that down, because 10 will break down to 2 times 5, right? And then the 3 and the 5 on the bottom is already there, so that's why I just wrote it out that way. I leave it alone, okay? So let's take a look. Is there anything in common on the top and the bottom? So usually I'll just go through the top. I'll go the 2, the 5, the x plus 1, then the x plus 3. Once I go through the top, then I'm done, okay? So is there 2 in common on the bottom? No. Is there 5? Yes. This 5 and this 5 is in common, so they go away. Is there x plus 1? There is x plus 1. Is there x plus 3 on the bottom? Yes, there is an x plus 3. Awesome. So all of those canceled out. So what do I have left? On top, the top, I only have a 2 left. What do I have left on the bottom? The 3 times the x minus 1. Okay? So then, that would be my answer. Voila. Okay? So it's just as simple as that. The downside is that you have to factor. And step 2 is just to simplify. Or you need to do some canceling. Okay? Or see what's in common. Okay? So that's what you need to notice. Okay? Actually, let me do it this way even. Let's go one better. So you see what's left. And that's where these come into play. Okay? So that's where you see that I wrote down the yellow goes away because they will all equal to 1. And then what's left is the 2 on top, the 3 on the bottom, and the x minus 1 on the bottom. And that's it. Okay, so that's how you do that. Is it going to get worse? Yeah, it's going to get a little worse. Let's do one more example and then we'll end this video. So let me see here. I might have a z squared minus 49 over a z squared times a z squared minus 7z over a z squared, oh boy, plus z minus 56. Oh boy. Okay, so let's do this again. Let's change this to red. Let's change this to blue. Let's change this to orange. And let's change this to purple. Okay? All right, so let's see what we have to do outside and what we can kind of stay just within. So let me draw these back again. Boom. 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 Okay? So, the red is the difference of two squares, okay? So again, if you remember correctly, when I came up here, I talked about factoring, right? If it's two terms, is it the difference of two squares, right? If it's three terms, AC method. If it's four terms, factored by grouping. So we go, okay, is there a GCF with the red? No. Is it the difference of two squares? Yes, the difference meaning is subtraction. The z squared is z times z. The 49 is 7 times 7. So that means this is going to factor down to z minus 7 and z plus 7. Okay? The blue, z squared. Well, that's just z squared. Okay? The top right, first, GCF. There is a GCF of z. What do I have left? A z minus 7. Okay? Now, if I look at the z minus 7, is that the difference of two squares? And the answer is no. Okay? Because the z is not a perfect square. 7 is not a perfect square. It is a difference, but it's not of two perfect squares. Okay? The purple, however, I do have to do some work. So a times c is equal to negative 56. B is equal to positive 1. So my two number must be a negative 7 and positive 8, right? Because if I multiply those two, negative 7 times positive 8 gives me negative 56. If I add negative 7 to 8, I'll get a positive 1. So that means I have a z squared plus, oh, sorry, because I got to split that, minus 7z plus 8z minus 56. Down the middle. GCF in the first group is a z, leaving me a z minus 7. GCF in the second group is 8, leaving me a z minus 7. So I got a z minus 7 and a z plus 8. Okay, so that's where it's going to be. Z minus 7, z plus 8. Okay, so notice how I'm doing whatever work I have to do on the side, I'm literally doing on the side. Okay, so if you want to fold your piece of paper in half, right? So as you're doing the problem, leave the right side for work and the left side is just doing the problem. So that I'm not interrupting anything, I'm not going to get anything lost. The left side is still organized, the right side is just my work that I need to get these things factored. Okay, so when I multiply these, here we go. I'm going to have a z minus 7, a z plus 7. Let's bring this z all the way up to the front here, just because it's all alone, and a z minus 7. Okay, so what's on the bottom? The bottom is going to be a z squared times a z minus 7 and a z plus 8. Okay, so when I multiply, it's going to be top times top, bottom times bottom. Okay, so again, I ask myself, what is in common? Look at this. Let me do this right here. This is a z times z. So now I can say a z is in common. Is there a z minus 7 on the bottom? Yes, there it is. Is there a z plus 7 on the bottom? No, there's not. Is there another z minus 7 on the bottom? No, there's not. So that means, what do I have left? I got these two left on the top and these two left on the bottom. So that means I have a z plus 7, a z minus 7, and the bottom is going to be a z times z plus 8. Okay, so there it is, and that is my answer. So let's box it. Boom, done. All right, so again, I factored top and bottom, and then I basically multiply, which puts everything on top with top, bottom with bottom, and then I see what's in common with top and bottom so I can cancel, and then whatever's left, it would be my answer. Okay? I hope this helped. If you have any questions, let me know.